Okay, let's check that everything is visible. Yeah. Can you see my screen? Yeah.
Yes.
Okay, that's great. Okay, let's start. We have some. We are very happy. We have a midterm that is approaching. So I decided to kill 2 rabbits at once.
Excuse me. When will we have a midterm? On which date?
Piotr send me the information. Just let's check. Just a moment to be sure. I know that it's closed. Okay. Okay, let me copy the information. I was thinking that Peter will forward to the group. Okay, let's copy here.
Just as far as I understood, there will be not right now midterm, but in November. Is it correct?
That's like this. Yeah, like this. Yeah. I understand that it's 20. That is October 20.
We hear this first time.
Yeah, but I understand that I'm the guy who is arriving with bad news, and so probably you will kill me. But that's not my fault. Sorry. Okay.
No, we understand. We are actually glad that you told us.
Are you sure that it is October 20 and not 21?
I will check, but I think yes, Piotr has written in our internal teachers chat that that's for sure.
Okay. Okay, thank you.
So I think that's like this. So that's information from the teachers chat.
Is this like homework?
Okay, so let's discuss about the home assignment. The home assignment. Okay. So I decided to kill two rabbits. The first one is while you are doing this home assignment, it copies the structure of the exam. Obviously, it's a little bit harder than exam because it's home assignment, and on the exam you can't use internet, you can't chat with your friends. So the structure of exam will be exactly the same. So you will have 6 problems, and if you look at the problems, so you will see that, okay, the first one is about Markov chains. Okay, the first one problem in the exam will be about Markov chains. A little bit easy, a little bit less. The number of questions will be a little bit less because in a home assignment you have more time. The second question is about moment generating functions. So, okay, the second question will be about moment generating functions. The third question is about probability limit. So the third question will be about the probability limit. The fourth question is about Poisson arrival process, and so on. So basically, the question number 5 will be about conditional expected values, conditional variances, and the question number 6 will be about sigma algebras. So if the home assignment copies the structure of the exam, it's a little bit more difficult. So if you say, oh, that's very hard. Yes, on the exam, it will be a little bit easy because we understand well that you have less time to think during the exam. Okay, but the structure is the same, and you can also check the questions from the past exams. You can choose so you see there are 6 topics, and you can also look at the past exams. What about the deadline? Normally, so at least you should have at least 1 week plus 1 day. That's normal, at least 1 week plus 1 day. So it is let's say 22nd, 22nd October. So let's set the deadline for 22nd October. So while you are solving it, you will prepare for the midterm, and but you are not obliged to write it carefully before the midterm, and hence you can just try to solve it and send it after the exam, after the midterm. Okay, any questions about the deadline, about the structure of the exam?
Not yet.
Okay, so I understand that news are bad, but there are problems with free rooms, and I'm sure that Peter was a little bit constrained by this factor of missing rooms. So I thought he has done his best to make to choose a date, but we are not too mighty in choosing the date of the midterm. Okay, so let's check probably the hardest topic, the topic of sigma algebras. I think the topic of sigma algebras is rather hard, so let's discuss the sigma algebras and some more problems. But okay, let's speak about the sigma algebras. First, intuition. So we need intuition, and then the formal definition. But first, the intuition. Let's consider X is a random variable. And let's speak about sigma X, the list of all events. So that's informal definition. So that's not very rigorous, but let's start with this a little bit informal definition. The list of all events that can be stated in terms of X, and this list is called sigma algebra generated by X. So it's called sigma algebra generated by X, but normally that's the list of all events, of all the events that can be stated in terms of X. Okay, let's solve an example, an exercise using just this intuitive definition. Let's consider the random variables exercise. Let's consider the jointly distributed discrete random variables, X that is equal to minus 2, X that is equal to 5, X that is equal to 2, Y that is equal to 0, Y that is equal to 1. And let's find the sigma algebra generated by Y. Let's find the sigma algebra generated by X squared. Let's find the sigma algebra generated by absolute value of X times Y. Yeah, I think that's no, that's too much. 1, 2, 3. Yeah, that's okay. Let's find these sigma algebras. And here are the probabilities: 0, 2, 0, 1, 0, 1, 0, 3, 0, 1, and that's 6, that's 2.
Yeah? I'm sorry, can you hear me?
Yes.
I wanted to ask a question. The intuition is not really understandable, so the last of all events that can be stated in forms of X. So we have some sequence of events, And
So
like
okay, let's discuss. So let's discuss. Okay, so what what events I can state? I can formulate. I can phrase in terms of y. Okay, I can say that y is 0. That's an event that can be stated using y. Yeah, if I just use in constructing my sentences, I will use only y. Yeah, I will not refer to the random variable x. I will refer only to the random variable y. I can obviously say y is equal to 0. It's an event. Okay, I can say y is equal to 1. That's an event. I can say y is bigger than -5. That's an event. Yeah, I can say y is less than 6. That's an event. I can say y is bigger than 100, and so on. Yeah, there are many events that can be stated in terms of y. So when I construct these events, I use only y. Yeah, I do not use x or w, or I don't know, n, or some other random variables. Okay, this is a very big list. I can say, for example, cosine of y is less than 1/2, or I can say that, I don't know, y squared plus y cube is bigger than 15. There are many events that can be stated in terms of y. But in this toy example, many of these events coincide. Obviously, if you look at this particular situation, y has only 2 possible values. So the event that y is bigger than -5, basically, it is always bigger than -5. Yeah, it's not in this particular case, it's not possible that y will be less than -5. Yeah, and hence that's a whole omega. Yeah, we have no possibilities for y to be less than -5. And so basically that's the same event in this particular case, that y is bigger than, is less than 6. And for example, in this particular case, in this particular example, the event y bigger than 100 is impossible. In this particular case, you can't have y bigger than 100. So it's just empty set. It is also impossible to have y squared plus y cube bigger than 15, yeah, in this particular case, because we have only 2 values possible for y, 0 or 1. And hence, our sigma algebra of all events that you can state in terms of y is very small indeed. Basically, we have the event that y is 0. We have the event y is 1. We have the event omega, and we have the empty set. All other events that you can state, you can phrase in terms of y will coincide with one of these 4 events. So for example, if I say y is less than 1/2, this will coincide with y equal to 0. If you say y is bigger than -7, that will coincide with omega. If you say y squared is bigger than 10, that will coincide with empty set. Y squared is equal to 1. This event will coincide with y equal to 1, and so on. Yeah. When I try to formulate, to phrase all events that I can phrase in terms of y, each event will coincide with one of these 4 events. That's okay? Any questions here?
yes, what is this like third symbol?
Omega. That's a Greek letter.
What does it mean?
That's empty set. That's Greek letter omega. So let's like So in Greece.
So what does it mean?
It means the event that always is true. So this the event that always happens. So the event, so the trivial event that always, the trivial event that always happens.
Is it like a universe for sets?
Yeah, it's not. It's universe for our random experiment, not universe for all sets, but the universe for our random experiment. And empty set, that's a trivial event that, how shall I continue this? What should I write here? Anyone? How shall I continue with empty set? Yeah.
That never happens.
That never happens. No? Yeah, that never happens. There are
so I have a question. If we have like y is more than like some epsilon that is normally distributed, will it be a sigma algebra?
So let's discuss more complex case, and here we will need formal definition. For discrete case, that's enough to have this informal definition. For continuous case, we need intuition is a little bit not enough. Okay, let's move on. Yeah. We will reach the continuous case in a few minutes. Just be patient. Yeah, let's start with discrete random variables, and then we will state this intuitive definition more precisely. But for the moment, for discrete random variables, that's completely okay. All the list of all the events that can be stated, phrased in terms of a random variable.
Yeah, okay, but I think I can ask a similar question regarding like the discrete case. For example, we have like some binomial distributed variables that can only take values 0 and 1. If we say that y is equal to this variable, will it be a sigma algebra, or it will not be because we have some random variable except our
if you use
y?
So if you use other random variable, so let's say y is equal to z, you have two random variables. So there are so there is a random variable generated. So let's, and this is the question A, we have already answered. B we will, and C and D, let's say how many events are there in sigma of x and y. So if we consider all, so you may consider all the events generated by two random variables. So if you have more than one random variable, so if you have y is equal to something else, so you are speaking about the sigma algebra generated by two random variables. You have knowledge of two random variables, and you can list all the events you can phrase in terms of two random variables. So if you are asking whether one random variable is equal to other random variable, then we need to have the sigma algebra generated by two random variables. Actually, probabilities, these probabilities are not used in the definition of sigma algebra, as you see, because sigma algebra is just the list of events, and these probabilities are not used. In the definition of sigma algebra, I have specified them only for illustrative purposes, just to avoid parameters because when someone write parameters, 1/2 of the students, they are scared. So, but we can you can use, let's say, binomial distribution or any distribution with the same values. That doesn't matter for the sigma algebra. That's better, or I haven't got your question?
Yes, that's better. Thank you.
Okay, let's move on. What about sigma squared of sigma of x squared? All the events that you can state in terms of x squared. Imagine that you know x squared. You don't know the value of x. You know the value of x squared. That's the difference. Yeah. For example, let me copy the to simplify my exposition. I will go to the next page and let's write it here. Okay, now let's move to sigma of x squared. Sigma of x squared. And obviously, for example, the event x is -2. That event is not in the sigma algebra generated by x squared, because you can't phrase it, you can't state it using just the value of x squared. If you have knowledge about the x squared, you can say x squared is equal to 2. Oh, sorry, to 4. Yeah, x squared is equal to 4. But this event is the union of x is equal to 2, union x is equal to -2. You can say x squared is equal to 25. So you can separate the value 5. Yeah, but you can't separate x equal to 2 and x equal to -2 in our case. And once again, you have trivial events. Every sigma algebra basically contains trivial events. So I can say x squared is bigger than -5, but x squared is always bigger than -5 if we speak about real numbers. Yeah, then if we do not include complex valued random variables, and complex valued random variables are used in the proof of central limit theorem, for example, but we are not speaking about complex valued random variables here. So x squared bigger than -5. That's a trivial event. That's omega. That's always. For all 6 outcomes, x squared is bigger than -5. So that should be in our sigma of x squared. And x squared is less than -5. That never happens. That's trivial event. That is also included in the sigma algebra. And hence, my sigma algebra, sigma of x squared, has once again 4 events. X is equal to, x squared is equal to 4. X squared is equal to 25. Trivial event. And 2 trivial events, done with the first one that always happens, and the second one that never happens. And so we have found our second sigma algebra. That's okay? Any questions?
Not yet. No.
Okay, now let's move on to something more difficult. Now you know
Wait,
the value.
sorry.
Yeah.
Can I ask a question?
Yes.
Okay. We included the empty set and omega. Now I have no question. Thank you.
Okay, now let's move on to the point C. Let's calculate the sigma of model x times y. First, let's check the possible values. What are the possible values for absolute value of x times y? If you look at our table, then you can see that absolute value of x times y will be either 0, either -2, either 2, either 5. Yeah, there are 3 possible values. Yeah, and hence, basically, that gives me a lot of information. I can say that, for example, the event absolute value of x times y bigger than 1 is basically the same event that absolute value of x times y is bigger than 1 over 2. Yeah, that's the same event, because basically that's x absolute value of x times y is equal to 2 or 5. Yeah, these events, they do coincide. Or for example, the event absolute value of x times y is 0 is the same event as absolute value of x times y is something more interesting, sine of absolute value of x times y is less or equal to 0. Yeah, obviously when x times y is 0, the sine is 0, so that's the same event. So when you phrase events, you may use any function, or for example, that's the same event that log of absolute value of x times y plus 1 is equal to 0. So there are many ways to state the same event when you can use only absolute value of x times y. So let's write all the events. So let's write our big list. So, okay, we may start with trivial events. These are trivial events. What else? Absolute value of x times y is 0. Absolute value of x times y is 2. Absolute value of x times y is 5. But I can also include all inequalities, yeah? Absolute value of x times y is bigger than 1. Absolute value of x times y is not equal to 2. Or maybe not equal to 1, yeah? Not equal to 0. Absolute value of x times y not equal to 5. And that's all. Yeah. Any questions? Everything is clear, or you are lost? Why this list is so big, or why this list is so small? Any questions? Or you are afraid that's too easy or too hard?
Just afraid.
Just afraid. You just consider all the events you can phrase, and you omit events you have already stated. For example, if absolute value of x times y is 0, you may write this event in many ways. You can say, for example, absolute value of x times y is less than 1. Absolute value of x times y is less than 1.1. There are many ways to write the same event. Yeah, there are many ways to write the same event. You can say, for example, if you observe the result of a dice throw, then you can say, oh, the result was 6. Or you may say the result was bigger than 5. That's the same event, formulated differently, but they're the same event. Or you can say the result was divisible by 2 and 3. Yeah, there are many ways to phrase, to say the same statement using synonyms, and hence when we write the sigma algebra generated by some random variable, we analyze all the possible cases all the possible events, we list them without repetitions. So this event is already in our list, so we do not include the same event phrased differently. I hope that's better.
And instead of writing like set modulo x times y is not equal to 0, we could just write like modulo x times y equal to 2 or equal to 5, right?
Yes, in this, for example, event, you may state it in many different ways. You may say, first of all, you may introduce W for absolute value of x times y. It will save time. And you may just write W belongs to 2 or 5. Yeah. You may write like this. Yeah.
Then I have a question. So, like, there is a notion as power set. Could we say that a sigma algebra, like for a discrete case, is just a power set plus omega?
You don't need to add omega, and you need to specify the power set of what, because you
power
see,
set of like this expression that is in sigma brackets.
Yes, basically yes. The sigma of x times y gives us the partition of the whole omega. You may say that the whole omega is represented by three is partitioned into 3 sets. W is absolute value of x times y. I'm lazy. W is equal to 0, W is equal to 2, W is equal to 5. Yes, this is omega is partitioned into 3 disjoint events. Yeah, omega is just this W equal to 0, or W equal to 2, or W equal to 5, and they are disjoint. Yeah, these events. Omega. Let me write omega. Omega is partition of 3 disjoint events. And yes, you are right. You can just consider the power set this. So let's say P is a partition. Let's say this. Let's name the partition L. So we have these 3 events. Yeah, and you are completely right. Oops, sorry, not 1 but 2. You are completely right that sigma algebra generated by our random variable W, once again W is absolute value of x times y, I'm a little bit lazy, it's just indeed all the subset that you can generate using L, and you don't need to add an exclusion, some special rule for omega, because omega is so when you say I will include that one, and that one, you will have omega. If you will not include neither event, then you will get empty set. If you include sigma of W is the power set of 2 to the L. If you include that one, do not include this one, include that one, you will get the set absolute value of x times y is not equal to 2, and so on. So you don't need to make exceptions. So that's the general formula for the discrete case. You're completely right. That's true. So you just and hence you will have 8 events. Yeah, you will have plus plus plus, minus minus minus, plus minus plus, minus plus plus, plus plus minus, minus minus plus, minus plus minus, and plus minus minus. So you will have 8 events in the sigma algebra, sigma of W. And you can make correspondence. For example, this one is absolute value of x times y is 5. Any questions?
Maybe not yet. I personally need just some time to understand what is going on.
Okay, yeah. Okay, now let's move on. Let's okay. The last question: how many events? I forgot the question. How many events are there in sigma of x and y? Events are there in sigma of x and y. So now you can phrase the events using 2 random variables. So you may construct something like x is less than y, or you can say x squared plus y squared is equal to 5, or you can say x divided by y plus 5 is 7, or you can say x is bigger than y or equal to y. So there are many events that you can phrase using 2 random variables, but some of them obviously will coincide. In our case, let's recap our table. Yeah, let's recap our table. And hence we see, for example, that x squared plus so for example, this event x over y plus 5 equal to 7, that never happens. Yeah, x is never divisible by 7. Yeah, so hence that is just empty set. That's another name, strange long name for the empty set. This never happens. And many other events are just different names for the same event. For example, x squared plus y squared is equal to 5. That may happen, but basically that seems there is only one possibility that x squared plus, oh sorry, two possibilities. That means that absolute value of x is 2 and y is 1. That's the same event, yeah. And you can also say that is x is less than 5 and y is bigger than 0. That's also the same event. Yeah, x less than 5, that means only minus 2 and 2, and y is 1. The same thing to say that y is bigger than 0. There are many ways to phrase the same event. Okay, but let's check how many events, how many different events do we have in our sigma algebra. So now, how we will not write the full list. The full list is very big. It will be we can write it, but there are many events, but we can start writing it. For example, x is equal to -2, y is equal to 1, x is less than 5, y is bigger than 0, and so on. There are many events in this list, and let's analyze how many events are there in this list. Obviously, if we can use x and y in our phrase, in our statement about the event, we can obviously separate these outcome. To separate this outcome, we can say x is equal to -2, y is equal to 0. We can separate every other outcome. We can separate every other outcome. We can say x is equal to 5, y is equal to 0. But if we can separate every outcome, then we can calculate the union of them. Yeah, you can say this outcome or that outcome. So you can consider all the unions. And so basically we have 6 outcomes here. 6 outcomes. So x is equal to -2, y is equal to 0, and so on. We have 6 outcomes. The last one, x is equal to 5, y is equal to 1. And we can either do not include neither, and hence we will have empty set. We do not include the first outcome, we do not include the second outcome, and so on. We can include every outcome. We will get omega, and we can combine them. For example, we can include all events where x is equal to -2. So here and somewhere else. Yeah, we can say that x is -2. X equal to -2, that's the union of 2 outcomes. And hence in total, we will have, I prefer to write cardinality, the number of objects. It's called cardinality. Cardinality of sigma of x and y, the number of objects is 2 to the power 6, because we can either include or do not include each of the outcome, and hence we have 2 to the power 6 elements in total. Yeah, will make 64 events in this sigma algebra, and that's a very long list, so we will not write it explicitly, but we can say that it has 64 elements. Any questions?
Why 2 in power of 6? So 2 because 2 variables, but why power of 6?
No, not because 2 variables. We have 6 outcomes, yeah? Yeah, we have 6 outcomes. Imagine that I write, for example, plus, minus, plus, minus, minus, minus. So imagine that for each outcome, you may write plus or minus. Take it or leave it. And hence, how can I phrase this event? This event says y is equal to 0 and x is not equal to 2. Yeah, that event, I can write it using 2 pluses. So the first outcome is included in this event. This, you see, these event can be described by 2 pluses and 4 minuses in this table. Yeah. Okay.
Yes.
And how many events are there? In how many ways I can put minus or plus in 6 cells? I have 6 cells in my table, and every cell is either plus or minus, and I have 6 places for plus or minus sign. So hence, so it is 2 to the power 6. 2 is not the number of x and y. So 2 means plus or minus, and 6 is the number of cases of outcomes I distinguish. Yeah. So
it's like the indication if we take or like some value in our set or we don't.
Yeah. Exactly. So that's why I have written 6 minuses here. Yeah. All pluses there. Yeah. So if I put plus in every cell of my table, I will get the trivial event that always happens.
But like, why we take 2 to the 6th power, like?
Because I can encode every event by 6 signs plus or minus. So if you put 6 signs in the table, you can describe that you are describing an event. For example, if you put, let me choose another color. So if you put, let's say, plus, 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 minus, 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 that's the event y is equal to 0. And we are constructing the collection of all events you can trace using only y and x random variable names. Is it better?
Yes, I guess. Thank you.
Okay, I understand that's very abstract. And indeed, we are working with list of events. Yeah, we are not working with one event. Yeah, we are working with list of events. Why do we need this language? This language obviously is needed to convey information because I can now make forecast. So that's a standard language when you deal with modeling forecasts. For example, you can say, "Oh, I have a expected value given. I have some expected value of y given that I know x." Yeah, so. Or I may say expected value of y, and my knowledge is described by x and let's say w, and that's our way to model information. So it's widely used in forecasting, this language of sigma algebras, and it is also used in abstract definitions in proofs. For example, probably you know the definition for independent discrete random variables. Yeah. For example, do you know the definition? How imagine that x and y are discrete random variables. Imagine that x and y are discrete random variables. How we define that x and y are independent? How we define the idea of independency? What shall we say? The probability that x is equal to small x and y is equal to small y is equal to which, to what? To what?
Multiplication of separable probabilities.
Yeah, you're right. You also probably know the definition of independency for random variables with densities. Yeah, for example, x and y are independent, and we have density fx of x and fy of y. And how to say that they are independent? Oh, you may say the joint density, yeah, and they have joint density. Joint density is defined. In this case, you may say f of x and y is fx of x multiplied by y of y. Okay, these are particular case, and the general definition, the abstract definition, you may say in the following way. You may say x and y are independent if every event a from sigma of x, every event you can phrase in terms of x, and every event b from sigma of y are independent. Yeah, and that's the universal definition. X and y are independent. So that's the abstract definition that works for continuous variables, for discrete variables, for when x is continuous and y is discrete, when x is neither continuous nor discrete and y is neither continuous nor discrete. There are many other types of random variables. They can be a mixture of two. And that's the definition that works. The only problem that we need to define to work our informal definition to a formal one, the list of all the events that can be stated. Well, what is mathematically stated? Yeah, that's a little bit imprecise in terms of x. Yeah, we need to make it a little bit more precise, because okay, the list of all that can be stated. What that means stated, what has been phrased. Yeah, it's intuitively clear, but let's be formal. Basically, the formal definition, sigma of x. Now the formal definition, the official definition. That's a little bit harder, but okay. First, intuitive idea. We can compare x with every number. So first idea, idea one, we can compare x with any real number. And mathematically speaking, that means x less than 5 belongs to sigma of x, x less or equal to 6.2 belongs to the sigma of x, and so on. So for all real t, the event x is less than or equal to t belongs to the sigma algebra. So that's the first requirement. And then the second requirement, idea one, and idea two. You can, if you can formulate one event, some event in terms of x, you can formulate the complement. If you can say something like x is bigger than 5, you can say x is not bigger than 5. If you have said cosine of x is bigger than 2, you can say cosine of x is not bigger than 2. So you can, if you can phrase one event, you can phrase the opposite event. So idea 2, if some event A, you can state it in terms of x, then you can state the opposite event. Yeah, probably you write it with bar above, but they're the same thing. A complement or a bar, the opposite event. And idea 3, that you can combine events if you can state in terms of x the event A1, you can state in terms of x the event A2, and so on. If A1 can be stated in terms of x, you do not use the random variable y or random variable w to state the event A1. If you can state the event A2 in terms of x, and so on, then obviously you can state the more complex event, the union of all AI. You can state this in terms of x. And so that's a formal definition of sigma algebra generated by x. Okay, any questions? Oh, that's a formal definition of a sigma algebra generated by x. So just let's check. If, for example, x is binomial with n equal to 10 and p equal to 0, how many events are in sigma of x?
Two to the power of 10?
Yeah, exactly. You can say that sigma of x contains a lot of events. Yeah, we have x is equal to 5. Yeah, that can be stated. Or you may say x is bigger than 6. Or you may say x is bigger than 2. Or you may say x is not equal to 4. There are many events that can be phrased in terms of x, and hence indeed, you are almost right. You are a little bit wrong because you have 0, but you got the idea. I see that you understand. So there is a small. So there are 11 values, not 10. So x can be 0, 1, 2, 10, and hence you can separate each of these values. You can separate it, and hence you can combine all these 11 values in all possible combinations. Yeah, and hence you have the number of events in this sigma algebra. So that's the number. So when we say card something, that's the number of objects in something. The cardinality of sigma of x is just 2 to the 11, so it's 248. So there are many events in this place. So sigma algebras are hard to get, are hard to describe, but we can describe them using random variables. During your lecture, you had the abstract definition of without explicit reference to x. So you see that this idea is satisfied by all sigma algebras independently of the name of the random variable. This idea 3 is satisfied by all sigma algebras, and if you look at the idea 1 then you will understand that the number of the events included due to idea 1 is different, because if x takes only 2 values, you will include less events in the due to idea 1, and hence the minimal number of requirements that are imposed on all sigma algebras. So the abstract definition of a sigma algebra, so we call F, is the definition that you had during lectures. F is a sigma algebra. You may implicitly add generated by some random variables, yeah, or you may do not add this. If, and we have the minimal requirement idea 1 empty set belongs to F, idea 2. If you can phrase some event, you can phrase the opposite event, the complement. If A belongs to F, then a complement belongs to F. And idea 3, the same. If you can phrase A1, A2, A3, and so on, A4, and so on, in terms of some random variables, then you can state, you can phrase the union. Why I have chosen the red one? Yeah, let me change the color. Ah, what is change? Wow. Okay, that should be black. Never mind. Hence, that's the abstract definition of a sigma algebra. But the reason for this definition, I've tried to convey the reason to arrive at this definition at the end, because our goal to represent information during using sigma algebras, and hence the information stored in random is stored in random variables, and we use sigma algebras to describe them. Why a funny name? Why a funny name? Probably you are afraid of a funny name. Why just not the list of events? Yeah, or why just not list of events? Would be more probably easy to get. So why strange name? Why we have why such a strange name? Sigma algebra. Why it's algebra? Why such a strange name? Sigma algebra. Why not just a list of events? I don't know why it has been. I know the reasons. I will explain them in 1 or 2 minutes, maybe. But that's more impressive when I say sigma algebra instead of just list of events. And sigma algebra, that's more. You can impress, for example, your friends. What were you doing during the lecture? We were discussing list of events. Oh, we were discussing sigma algebras. Yeah, that sounds much more important. Okay, so that's probably the first reason. And the true reason is that there are like some analogs to algebraic operations inside. For example, so when we speak about, so there are 2 operations inside this set, inside this reason. So what is algebra? Algebra in high school, yeah, in high school, what is algebra? Algebra, you are studying something like 5 plus 6, 5 times 7, so that's algebra in school, yeah. So it's 11, yeah, that's 35, and so on. That's algebra in school. And here you have operations that behave like plus, like additional multiplication inside this list of events. You have two operations. One behaves like plus. This is delta operation. That means the difference between two sets. The difference between two sets. But that's the Euler diagram for the difference of two sets. So basically, that's A minus B union B minus A. And this operation behaves like plus, and ordinary intersection, that operation behaves like multiplication. So all the rules you can imagine are valid for these two operations inside sigma algebra. So you can do all the simplifications you remember. So for example, probably you know that 5 times 3 plus 7 is 5 times 3 plus 5 times 7. And you can say that A delta, A intersection B delta C is just A intersection B delta A intersection C. So basically, why such a strange name, sigma algebra? Because it behaves like algebra. We have analogs to multiplication and analog to the addition in this list of events. Yeah, the analog of plus operation is delta of sets. The analog of multiplication is the intersection of sets. You can check this. You can check this using Venn diagrams. But this is the reason, the true reason for the for this name, why it's algebra. And sigma, that's like okay. So that's the so this. Okay, so that's the reason for the name algebra.
Okay.
And it sounds more important when you say sigma algebra instead of list of events. I think that's all for today.
Wait.
Yeah.
Okay, I think I have a few questions. Like one is just more organized.
Sorry,
organizational.
the echo is awful. Sorry, the echo is awful. I think there are two phones that are. The echo
Okay,
is
right
awful.
now is better.
Actually, I hear you perfectly.
Okay. Maybe that the effect of something. Okay, I will try to yeah. Let's try once again. I will be more patient.
Okay, do you hear me well now?
Yes, I hear, but with echo. But okay,
I see. Okay.
I will.
Just one question more about, will be there additional consultation before midterm first?
Additional?
Consultation before midterm.
Yes. Yes. We understand that that's a little bit of short notice, but that's not completely our fault because there are problems with free rooms, and we will do yes. So the answer is yes. Yeah.
Okay. Then.
So my advice: try the home assignment. You don't need to hand in it before exam, but try it before exam. It's a little bit harder than the actual exam, because that's normal. During exam, you have no access to your friends, to internet. So that's a little bit harder. So don't be afraid if you say, oh, that's harder. Try to solve corresponding problems from the past exams. The link to the past exams is published on the wiki page. I will add the home assignment there. So that's my advice, and obviously we will organize some like question and answer session before it. Yeah.
Okay. Can you just repeat the idea of the last point? At least
the name. So why it has a strange name? The idea. Why it's named algebra?
Algebra. I do. Okay, I think I mean not algebra, but maybe of the example, like this D point idea of it.
Which idea?
D point. Ну, то есть это D пункт, который.
How many events? Yeah. How many events are there in sigma of x and y? So I try to count all the events that I can phrase using x and y. So I'm free to say something, x is less than y,
so
x
we try
is
to
bigger.
find, I see. So I think I get it a little bit now. Yes. So we try to understand all the possible comparisons.
Yeah.
And relationships
all the
which can be.
Everything, every possible equation, every possible inequality, every possible function. You can say cosine of x plus cosine of y is bigger than, I don't know, 0. Yeah. You may use any function, any function, you know. There are many events, but some of them do coincide. This is an example of two events that do coincide. This is a long description, that is a short description of the same event. Or this event x squared plus y squared is equal to 5. I can say it differently. I can say x is less than 5, y is bigger than 0. And the same event, just phrased differently. And I count, my goal is to count events without duplicate. Yeah. I count this as 1.
And I understood that you try to like calculate the number of the terms in the table, right? But maybe I'm not sure.
My
like
idea
was. Okay.
My idea was
it's
that
like we try to understand, try to calculate maybe all combinations of x and y, right? And then we just look in each of the spaces, so-called like empty space, which belong them.
Yeah, we just look at the smallest possible events that cannot be split further. So, for example, if you say y is 0, yeah, this event can be split using our information. We can split it into 3 sub-events. Y is equal to 0, x is minus 2, y is equal to 0, x is 5, and y is equal to 0.
Yeah, I see. So
2.
we just get all y equals 0 and just look all the specific cases that form this y equals 0.
So we are searching for the simplest events that can't be broken into parts. We are counting these simplest events that can't be broken if we state the events using x and y. And we have count only 6 such primitive events. For example, x is equal to minus 2, y is equal to 0 is one of such primitive, simplest events. Yeah, we have such 6 primitive events, and then we go back, we try to combine them, because if we can state this event in terms of x and y, and obviously it's stated in terms of x and y. Now we can combine it with other primitive events. And as we have 6 primitive events, we can either include the primitive event in the combination or do not include it in the combination, in the union. And hence we have a plus or minus choice for every primitive events. And hence the total number is 2 to the power 6.
Every 2 a plus or the minus, but like minus isn't like does not belong to the space, and we should calculate the pluses, or I'm just not getting the idea. Ну, то есть, что мы считаем это, мы же, по идее, минус же здесь обозначает то, что не принадлежит же.
Да, yes.
Ну, то есть должны посчитать, по идее, же плюс тогда количество.
Okay, let's write this once again. What is this? For example, plus. So this is plus, minus. Let's write this event. This event is x is equal to minus 2. Yeah. For example, minus, plus. This event is just y equal to 1. Yeah. And for all possible, if I put, for example, pluses like this, plus, minus, we can describe this. It's something like, how I can describe it?
То есть, как бы мы смотрим, то есть, как бы, по идее, каждое отдельное событие, комбинация, как бы, как x равняется единице, y равняется, ну да, там x минус 2, y равняется единице, the power. То есть, вот эти все частные случаи значения x и y мы как бы формируем каждую частью таблицы, которая как раз из плюсов и минусов состоит.
Yeah. Every if we put pluses or minuses in the table, we have 6 signs. We put 6 pluses or minuses in the table, and this can be stated in terms of x and y. I can state it as an event. So here I can say, for example, the parity of x and y is the same. The parity of x and y is the same. And I can write, I can create how many tables of plus and minuses I can create. I can create 2 to the power 6 such tables, and every table of 6 plus and minuses uniquely corresponds to an event that I can phrase in terms of x and y. Yeah, that's better.
Ага. Ну, то есть мы we just say that this whole table includes all the combinations of subcells that will combine all the events, right? That the whole table contains all combinations of subcells that each corresponds to the existing event, like x equals minus 2, y equals
x minus 2
1.
corresponds to a configuration of pluses and minuses in the table. Every event corresponds to a configuration
Yeah,
of
what
pluses
I'm saying.
and
This is what I'm saying.
Yeah.
Ну, то есть я пытаюсь сказать, что, ну, то есть, насколько я понимала, что по сути таблица является, что мы утверждаем, что таблица такая, что включает что означает все подкомбинации вот этих ячеек с плюсами и минусами, так, чтобы это, которые потом будут, кажется, соответствовать это нашему конкретному событию, да?
Yes. The table, the configuration of pluses and minuses as in the table describes the event that can be stated in terms of x and y. Yeah. So the number of events that can be stated in terms of x and y is the number of tables with pluses and minuses inside. And it's easy to count the number of tables.
But how we just, well, I think it's kind of, yeah, I think it's a cool idea. I just want to be sure how we are like know that this table contains all these like events.
Because
like I know
you can't
that
split the events into simpler parts. You can't. These are like atoms, and we construct new events using these atoms. So we are not. We can't subdivide these. For example, event x equal to -2, y equal to 0. These events correspond to the table plus, minus, 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 minus. And you can split the event into sub-events. We have specific value of x here, specific value of y here. So we can't split it into simpler events. For example, x is equal to 2 can be split into more simple events. Yeah.
Yeah, this is I get. But and so we can just and we just say that all these the smallest events can be combined to the bigger ones, right?
Yeah.
And then this is formed to the whole table. And this is why the end they all connects like one table, and then just we have all the unique events, but also so the ones which like overlaps are like x equals 2 and all the sub events.
Yeah. We combine primitive events. Events. Yeah, that's the idea. We combine.
Does it mean like to use tables in such cases when we have combined two combined variables of sigma, right? It's a good idea, like try to represent it into the table format, like to understand how to. Just I see that we have a kind of similar logic in C, right? When we were discussing that also how it maybe I'm not sure. Okay, I think understand how all the cells, right, work, the columns, but how we understand how formulated rows, like this like trivial event that always happens, right? And trivial event that never happens. But what are other rows? How we do understand like that x equals -2. But can be there, for example, a combination of events like x equals -2, y equals 0.
Just try to say, how will you describe, so that's just the question, how to translate a table into ordinary plain language. So for example, we have, so that was x is -2, x is 5, x is 2, as far as I remember, it was 0, it was 1.
Не, я просто пытаюсь понять именно, что мы записываем в строчке. What we do write in the rows, like, as a Ну, то есть я же не могу написать.
Там получается как бы варианты того, какие у тебя ивенты. То есть у тебя, например, вот x равно 2, y равно 0. Это у тебя, получается, будет ивент, когда x равен 2 и y равен 0.
Ну, вот это да, я понимаю. Я имею в виду тот столбец, который нам с плюсами и минусами потом мы обозначаем. Что столбцы у нас обозначают каждый вот такой отдельный комбинацию ивентов, да? А что мы в строчку записываем? Это я вижу, что у нас есть вот это сигма и пустое множество. А дальше у нас идет как бы x равняется -2. Это то есть мы так записываем отдельно x, y.
If you are discussing, okay, I think I've understood your question. So You just say here, yeah?
Не, что я имею в виду, что как мы понимаем, что вот, например, в качестве строчки у нас может быть x равняется минус 2. Вот.
Потому что
But
у нас такие значения изначально по дано задаче. Что это может быть
yeah,
x
that was
5.
the text of our original problem.
Так. Я насколько поняла, у нас есть этот листочек с этой проблемой? Или это
Yeah,
так? Я, наверное, тогда не
here it
совсем
is.
поняла.
Yeah, that's the exercise.
Я понимаю, что это exercise. I do understand that it's exercise. I just don't understand which one and where it lays. Okay.
No,
How it looks like the condition of the task? Ну, я просто насколько
this is the
поняла, что
question.
единственное, что мы...
Calculate, find sigma of y, find sigma
Yes,
of...
I do
So we are given...
understand. How many events are there in sigma xy?
Yeah.
I know this. Ну вот в той таблице, которые у нас есть минусы-плюсы, которые мы составляем, да, что где пустое множество.
Мгм.
Можете это пролистать,
Да.
да?
Пойдем туда. Да, вот сюда.
Не, это даже не там, а где в пункте D мы же это как бы пытались нарисовать. Вот эти комбинации.
Вот здесь?
Да, сейчас. Ну да, вот у нас есть 6 outcomes, да? Насколько
Да.
поняла, что мы вот здесь делаем это, чтобы такую таблицу, которую мы потом говорим, сколько событий у нас в итоге всего,
Мгм.
да? Столбцы у нас обозначают каждую комбинацию вот эту x, y, так?
Мгм.
А вот как что столбцы у нас включают? Ну, я поняла, что есть...
Ой, that just was an example. I don't care about the exact ordering. The main idea here was that a combination of pluses and minuses corresponds to an event. I don't care about the actual order here. So I will have two pluses. One plus
Я
will
понимаю,
correspond...
что столбцы не важно в каком порядке. Я не
Ага.
понимаю, как строчки сформируются. Почему мы вставляем, например, сюда x равняется минус 2?
I will consider all the events. There are too many events, so I have considered only 3 of them.
А то есть сюда может включаться в качестве строчки быть, например, x
Yes,
равняется минус 2?
yes. That's only...
This is
There are
what I'm
many
asking.
lines here. There are many lines here.
То есть столбцы вот конкретно это у нас комбинация x, y только, да, как событие.
So
А
the
строчки
total
у нас
number of
всевозможные
rows.
события.
So the total number of rows here will be 64 rows. I have presented only 3 rows. Yeah, that's a big. There are many rows, but I'm lazy. I have presented only 3 rows. Yeah.
Ага.
Еще этот power set из, по-моему, он в дискре был. Типа множество из всех возможных там подмножеств и их каких-то объединений.
Ну да.
Вот это типа оно, только для ивентов.
Разбиение. Partition. Разбиение.
Ну, то есть этот столбец это больше как пример, получается? Это
Yes,
мы пытаемся, типа, что...
Yes, that was an example, because we have said how many events? There are 64 events. Yes, if I will list 64 events, it will take a lot of time, so I have presented 3 of them, and then we have calculated the number. So.
Кстати, я насколько понимаю, то есть мы даже не считаем именно ту таблицу, которая у нас вот здесь нарисована с 6 outcomes, да? А что мы говорим, по сути, вот это 6, это то количество...
Pluses or minuses, there are 6 signs.
Ну да, что с этих столбцов с плюсами и минусами. А получается вот это 2, это у нас количество комбинаций вот этих всех
У тебя
Получается событие.
2, потому что ты либо событие берешь в какое-то подмножество, либо
Ну
не
да.
берешь. Вот. А 6, потому что потом там добавляются другие варианты. И всего комбинаций есть 6.
Мгм.
А можно вот спросить, почему у нас мы 2 определения дали, да, то есть они как бы там можно математически одно определение из одного в другое выйти или как?
The first one explicitly refers to some random variable. Yeah, the first one says the sigma algebra generated by X. What it should contain? It contains. We can compare X with any number. So that's the sigma of X, the sigma algebra. So that the difference is that's the definition of sigma algebra generated by random variable X, and that's just the definition of sigma algebra without the explicit reference to random variables.
And okay, so the definition for sigma algebra generated by X is just like narrow example definition, like the definition in general is a generalization of this definition, right?
Not really.
So
Every
two
sigma
different
algebra
concepts.
Every sigma algebra is generated by either one random variable or by a set of random variables. Every sigma algebra is generated by one random variable or by maybe 2 or 4 or infinite number of random variables. So every sigma algebra indeed can be restated as a sigma algebra generated by something. So, for example, imagine that you have something like x is equal to 0, x is equal to 1, x equal to 2, x equal to 3, and you have probability 0, 2, 0, 1, 0, 1, 0, 6, and let's imagine the sigma algebra f that contains just x less than 1.5, x that is bigger than 1.5, empty set, and omega. Yeah, that's not sigma algebra generated by X, but let's introduce W that is just equal to 1 if x is less than 1.5, and 0 if x, or maybe it's bigger than 1.5, and 0 if x is less than 1.5. And obviously my sigma algebra f is sigma algebra generated by the random variable omega, by the random variable w. Yeah.
Feels like the first definition of a sigma algebra generated by X is, ну, в общем, то, что это определение недостаточно как-то ограничено. Ну, вот как будто бы, вот если по этому определению судить, как будто мы можем добавить какой-то вторую случайную переменную вот внутрь этого sigma algebra сета, и это все равно останется sigma algebra. Да, ну то есть, например, если я скажу не x меньше либо равно t, а x плюс y меньше либо равно t, вот.
Если if you add y here, you just need y is less than 5. So if you have the second variable here, you just need y less than t belongs to sigma of xy. And idea 2 and idea 3 will take care about combination. So basically, you have something that is simple inside the sigma algebra, and idea 2 and idea 3 will combine in all sort of fashion.
Ну, я понимаю, что можно написать типа сигма от x и y, но я скорее имею в виду то, что нам ведь никто не запрещает сказать, там, окей, у нас есть А1, А2, А3, а давайте у нас А4, это будет на самом деле y плюс z, который к x ничего не имеет, и мы скажем, что оно тоже в сигма-алгебре. Ну, то есть в определении же должно быть какое-то ограничение, что мы там не можем взять и засунуть что-то, что в нем не должно быть. А вот как будто в определении такого ограничения нет.
Как нет?
Ну, а где?
Вот. Yeah, I see that. Yeah, I see. Yeah. We need to. So yeah, you're right. I see your point. Yeah, see your point. The smallest list that satisfies. Yeah, we need here to add the smallest list that satisfies. Yeah, you're right. Yeah, you're right. I've missed this. Yeah.
И также для этого, для второго
No.
определения, наверное, да?
No. The
Нет?
second has no reference, so it's the abstract definition. Any sigma algebra satisfies these three properties.
Угу. Хорошо, спасибо.
Okay.
А можно
I think.
организационный
Yeah.
вопрос насчет мидтерма?
Да.
Почему он у нас в пятницу, а не в субботу? Просто у нас пара по ТССП в субботу, а там другая лекция в пятницу. Вы не знаете?
I'm sure я уверен, что это вопрос наличия свободных аудиторий. Вот честно, можете попробовать Петра спросить, как он выбивал аудитории. Вот я не в курсе этой истории. Но, в общем, с аудиториями
я говорю, проблема
очень
в том,
напряженно.
что да, там в пятницу другая лекция в это время. Ну хорошо, поняла, спасибо. Да.
Это интересно.
Очень.
Какая?
Optimization methods.
Хорошо, окей.
Вроде
всех
как,
групп,
я не знаю,
да?
может быть, у всех. Может быть, там ее отменили, я не знаю.
Хорошо, я спрошу на всякий случай. То есть просто я в этом смысле всего лишь принес весть. Я не занимался заказом аудитории, я как бы немножко далеко в Китае. Вот. Поэтому я только принес плохую весть, и поэтому, наверное, на меня обрушился весь гнев. Но я не заказывал аудиторию. Я знаю только, поскольку имею отношение к нескольким курсам, что с этим проблемы. Вот. Не знаю почему, на Покровке большие проблемы с заказом аудитории, что даже там некоторые на факультете экономики там некоторые пары проводили в другом здании впервые там за сколько-то лет, не знаю, не на Покровке, хотя официально эконом учится на Покровке, даже проводили пары не на Покровке, потому что не хватает аудитории. Вот, такая беда. И поэтому сложно заказать аудитории для... Окей, я понял новость про то, что это может быть пересекается с Optimization, я задам вопрос.
Спасибо.
Вот.
Больше вопросов нет. До свидания.
Хорошо, хорошего вечера.